Students are related to SR01. Okay. Copy this link and paste in your old channel. Yes, sir. Yes, sir. Please. What is the date today? 21. 22. Hey, 21. Yes, sir. Yes, sir. Please. Right. So we are discussing about ideal solutions, right? Just a moment. Only 9 people joined. We will wait for another 2 to 3 minutes. Yes, sir. Please, please. Then we will continue.
Sir,
Shall we start, sir? So in previous class, what we are discussing, sir? What we are discussing? Ideal solutions. What are ideal solutions? What are ideal solutions? Huh? Which obeys Raoult's law are called as ideal solutions. Very good. Any other? Liquid A, liquid B, liquid AB interactions all are the same. Then also ideal solutions. Okay, accepted. You can say delta H0, delta P0, delta V0, delta S greater than 0, delta G less than 0. Ideal solutions. Other than that, all those things are available here. I don't want that. I want any other. You might have studied about Henry's law. You have studied about Raoult's law. Based upon both, some conclusion you might have made. I asked you to solve these 3 questions also. Have you solved? Now observe this graph, sir. Let me activate the pen just a minute. So Henry's law means, can I write P is equal to or PA equal to KH into XA, correct? Henry's law. Response, sir. Yes or no? Then what is Raoult's law, sir? PA is equal to PA naught into XA. So this is also Raoult's law. This is Raoult's law. This is applicable for what? Liquids. The solubility of liquid in liquids. This is applicable for solubility of gas in liquids, right? And that is also for sparingly soluble salts, sparingly soluble gases. Means amount of gas present in liquid must be negligible. Correct? Respond. Now, what this curve indicates? What this curve indicates? What that indicates? When XA tends to 1, KH tends to PNR. What is the meaning of it? When XA tends to 1, what is XA? Mole fraction of gas present in liquid. So amount of gas present in liquid is approaching 1. Means what is the meaning of it? Total gas is now liquid only. If a total gas is now liquid, then Raoult's law is applicable or Henry's law is applicable? Means KH approaches PA0. PA0 will never approach KH. Are you able to understand? Any questions in it? Right? So I am writing that point. Can I write that point here as a note? Can I write as limit XA tends to 1, KH is equal to PA0. Will you accept it or not? Response, sir. When XA is approaching 1, KH will approach to PM. Clear? Any questions in it? I think already you have plotted this graph, right? I am writing one statement, observe carefully. I am writing one statement. Solute gas obey Henry's law. Solvent liquid obey Raoult's law. Then I call this solution as ideal, or I will call it as a dilute ideal solution. AH approaches PA0. Will you understand, sir, by looking at these two statements? Will you understand what I am talking about this line? Clear? Any questions in that? Better I will write this as a note. And we are talking this about ideal solutions. Now we are talking about non-ideal solutions. So what are non-ideal solutions? What are non-ideal solutions, sir? Respond. What are non-ideal solutions? What are non-ideal solutions? Which do not obey Raoult's law? Or can I say liquid A interactions, liquid B interactions, right? These interactions either may be greater than liquid A, liquid B interactions. Will you understand? Or maybe less than liquid A, liquid B interactions. Will you accept this statement, sir? Will you accept this statement or not? If these interactions are equal, ideal, either greater than or less than. If that means they are not equal. If they are not equal, then they are called as non-ideal solutions, right? If this, what is the meaning of these two? Individual liquid solutions. This is mixture. These are individual liquids. This is, or we call it a solution. This is nothing but solution. These are individual liquids. Will you understand, sir? If I write like this, right? What is the meaning of this, man? Individual liquids molecules having more attractive forces than the solution means, what is the meaning of it? I have taken water. Water have attractive interactions or not? Due to, I am taking water molecule, man. Water have two lone pairs, two bond pairs with hydrogens. I am taking another water molecule. I am taking another water molecule here. Here also. Here also. There will be hydrogen bonding between these two, between these two, between these two, between these two. Between lone pairs of oxygen and hydrogen, there will be hydrogen bondings or not? How many hydrogen bondings each water molecule will form? 4. If you take ethyl alcohol or methanol, now what happens? To number of hydrogen bonds. What happens in case of methanol regarding number of such hydrogen bonds? Will be high or less? Right? Will be less. So if I consider this as liquid A, this is liquid B. Right? Liquid B is having liquid B interactions. Liquid A is having liquid A interactions. See, when they are present individually. When I mix them, these methanol molecules come in between water molecules. Between two water molecules, one methanol molecule will come or not if I mix them. Then what happens to total number of hydrogen bonds? Increased or decreased? Decreased. If a total number of hydrogen bonds decreased remains, total attractive forces decreased or not? Right? Now tell me whether individual liquids have more attractions or that mixture is having more attraction. That's what I told. Individual liquids are having more interactions than mixture. Correct? Correct or not? No. If individual liquid is having more attractions means the moment I add methanol, water molecules are moving away. Then what happens to net volume? Increases. Means if I mix 50 ml of water and 50 ml of methanol, total volume will not become equal to 100 now. Reason. Between water molecules, when methanol comes, what happens to attractive forces between water and water? Decrease. It means water and water is moving away. If water molecules are moving away, what happens to net volume of that solution? Becomes greater than 100. Correct or not? Means it is not obeying Raoult's law. So 50 plus 50, if it is equal to 100, then it is called ideal. If it is greater than 100 or less than 100, non-ideal. Now, observe this case. Here. Now I'm considering the first case. In this case, what happened to net volume is greater than what we generally expected or less than what we expected, right? So V experimental value is greater than V calculated. Generally what we calculate 50 ml plus 50 ml equal to 100 ml. But when I am doing that experiment, as the interactions between A and B are less, A molecules and B molecules will not come closer as we expected. As they are not coming closer as we expected, net volume will not be equal to 100. It will be a little greater than 100. Correct, sir? Any confusion in it? Means delta V is greater than 0. Response, sir? Similarly, now tell me, if they are not attracting effectively, what about their ability to convert into vapor? Increased. So they experience more vapor pressure than we expect. The molecules are not attracting. If they are not attracting means they can convert into vapor easily. If they are converting into vapor easily means the pressure generated is more than what we generally expect. Correct? Any questions, sir? That means what about delta P? Again, greater than 0. Alright, means I will write, here I am writing. Similarly, P experimental is greater than P calculated. That means delta P greater than 0. Will you accept this statement or not? Right? Response, sir? No. What is this P calculated according to Raoult's law? This P calculated is PA naught into XA plus PB naught into XB according to Raoult's law. Response, sir? You need to actively answer. Any confusion here? Clear now? Now, if two molecules attract each other, what happens to net energy? Increases or decreases? Energy will be released or absorbed when two molecules attract each other. Released means delta H becomes negative, so less than 0. Correct na? Pakka. Correct only na? If two molecules are attracting, when electron attracted by nucleus, the electron comes closer and closer, then energy will be becoming more and more negative. Means energy is decreasing or not? When two molecules are attracting each other, net energy will be released. Energy will be released. Means net energy of the system decreases. So stability increases. Or chemical bonding, structure of atom. We discussed the same. Correct or not? Here, do the attractions are as we expected or less than we expected? Less than we expected, right? If they are perfectly equal, if the interactions are perfectly equal, then there is no net attraction, no net repulsion. Then delta H will be 0. Now, in this first case, what is delta H value? Greater than 0. Reason? Interactions are less, means indirectly they are repelling. Indirectly they are repelling means, what about delta H? What about delta H? Greater than 0. What about delta S? Greater than 0. Delta G less than 0. Right? Response, sir. Now coming to this parameter. What about delta V now? Is it straight line or not? It looks straight line only, yeah? Right. Now what about here, sir? Therefore, what about delta V? Delta P? Delta H? Delta S? Delta G? Is it clear? What you have noticed? What you have noticed? What you have noticed? Whether it is ideal or non-ideal, always delta S is greater than 0 and delta G is less than 0. What is the meaning of delta G less than 0 means spontaneous. Means when I am mixing two liquids, do the liquids are mixing each other means they will form solution spontaneously, or I need to heat or cool or something. So mixing two liquids is spontaneous process. Then only I call it as solution. Then what happens to disorder? I have taken pure water. I have taken methanol. When I mixed them, they are not pure water nor pure methanol. Means what happens to disorder? Increased. Correct or not? Right. Both are not ordered, no? It is methanol is destroying the orderness of water. Water is destroying the orderness of methanol. So both are destroying the orderness of each other. So what happens to net disorder? Increased. Are you able to understand? That's why delta S is always greater than 0. Delta G is always less than 0. Remaining three parameters, that depends. Clear? Any questions? No.
Sir,
Yes, sir.
sir, can you show what you thought up to now, sir?
What is?
What you thought up to now, sir?
Nothing, man. Just now I started. Non-ideal solutions. This is all in previous class only, no? This is all we discussed in previous class.
Okay, sir.
Right. Now here, can I write P experimental value becomes less than PA naught XA plus PB naught XB. Accepted or not, sir? Correct or not? What is this? This is nothing but P calculated according to out, sir. Any questions? Now I am plotting a graph again. I am plotting a graph between vapor pressure and mole fraction. I am plotting a graph between vapor pressure and mole fraction. Let me consider here XA value is 0, XB value is 1. Here XA value is 1, XB value is 0. Now, what we have studied earlier, when we are studying about ideal solution, which I have taken more, PA or PB? PA, na? Observe, which I have taken more. PB is more. PB naught is more than PA naught. I am continuing the same statement again and again. Huh? So if it is ideal, this is PB naught. Let this be PA naught. Right? If it is ideal, I will get a graph like this. Correct? Huh? Response, sir. Net total solutions pressure also, you will get a graph like this. This line indicates P of solution. This line indicates PV. This line indicates PA. Correct, sir. This line indicates PA. This line indicates PB. This line indicates PA plus PB. That is nothing but equal to P of solution. Now it is deviating from Raoult's law, right? Right? Now observe the first case. First condition. When it is deviating, how it is deviating? Experimental value is greater than what I calculated. Means experimentally, if I am calculating PA, experimental PA value is greater than ideal PA. Calculated PA is nothing but ideal PA. Means this is experimental PA, sorry, calculated PA. So my experimental PA must be like this. Yes or no? Why I'm writing that? Why I'm writing graph in this way, man? Pressure X, right? It is showing positive deviation, means it is showing more pressure than expected. More pressure than expected means A is converting to vapor readily. At the same time, B is also converting to vapor readily. Reason, attractions between A and B is weak. If attractions are weak, A converts into vapor readily, B also converts into vapor readily. Means PA is more, PB also more. Na? So that's what I am writing. PA value is greater than, PA value is greater than PA naught into XA value. Accepted, sir? Same way, what about PB? PB value is also greater than are you able to understand what I'm going to say? So PB value is also greater than PB naught into XB. Then what about this total? This total also becomes greater than both. Response, sir. Then what is this? P is greater than P experimental is greater than. Instead of P calculated, can I write PA naught XA plus PB naught XB? Accepted? Response, sir. Acceptable or not? Yes. What do you mean by XA? XA equal to 1 means? It is pure A. If it is pure A, where is solution? Right? If it is pure A, then what is the pressure exerted on pure A? PA not only. That's why it has to reach that only, na? Always. Pure B. Then it should be PB not only. Whenever it is becoming a mixture of both, it is deviating from Raoult's law. That's what I am writing. Any questions? Clear or not? Same way, can you predict the graph here? Means, can I get a graph like this here? Accepted, sir? Here also I have to plot a graph like this. Here also I have plot a graph. Here I will write P experimental is less than P calculated. Here, this is the graph for A or B. This is the graph for. So PB is less than PB naught XB. And this is the graph for A. So PA is less than PA naught into XA. Any questions, sir? Right? Now, I call this as positive deviation from Raoult's law. Are you able to understand why I call it as positive deviation? Why, sir? Why I call it as positive deviation from Raoult's law?
Sir, it's greater than the actual value it has to be.
Yes. Then what about this indicates? Solutions showing negative deviation from Raoult's law. Any questions, sir? Do you have any questions, sir? No questions, na? Say something, yes or no. Perfect. Pakka. Say yes or no. Huh? Very good, sir. Just a small modification I will do. No questions, na? Perfect. You should not say anything. Huh? Now listen, sir, carefully. I'm coming back. Is this? right? So we kept that part aside, right? Leave that part aside. Now, before going to next concept, try to understand this. If a liquid is converting into vapor readily, means what happens to its boiling point, low or high? A liquid is converting into vapor readily means what happens to its boiling point? Boiling point is low. Means can I say vapor pressure is inversely proportional to boiling point? Vapor pressure is inversely proportional to boiling point. Accepted or not? Define boiling point. What is boiling point means? Boiling point of a liquid. What do you mean by boiling point? Generally, we write as TB. What is boiling point? Define it. Temperature at which? Temperature at which? Listen. At which PA becomes equal to P external. Vapor pressure of liquid becomes equal to external vapor pressure. Or I call this P external as P of atmosphere, or maybe equal to 1 atmosphere, right? Then that temperature is called as boiling point. Very simple. And I take in some liquid water in a beaker and I keep on heating it. We know that water molecules keep on moving randomly. If I keep on giving energy, they will move more randomly. They will make collisions with each other. And also they will make collisions with air molecules also. Right? What atmosphere is doing? Atmosphere is always attracted towards the center of Earth. Correct or not? Yes or no? So if I take a beaker of water and when I am heating it, I am providing energy and the liquid molecules which are present here, they are trying to escape out by gaining energy. They are trying to move away. But what atmosphere is doing? Atmosphere is trying to push it down, right? So I call this as pressure exerted by liquid. This is the pressure exerted by atmosphere. I don't call it as liquid now. I call it as gas. Why? When I'm giving energy, liquid is trying to, at the bottom of vessel, you will get bubbles, air bubbles, gas bubbles. Correct or not? When I keep on heating for so much time, that bubbles keep on sticking to the wall of the container only. They will not come out of the wall. Have you observed or not? While you are boiling water, when you keep on heating, that gas bubbles will be formed. That gas bubbles will not come out easily. When I keep on increasing temperature, slowly one bubble goes to the top. When you keep on continuing that heating, slowly all bubbles vigorously will start moving to the surface. Yes or no? Right? So that bubble is nothing but liquid which convert into vapor. So that is the vapor pressure of the gas. Correct? That liquid converted into vapor. That is the vapor pressure of that liquid. That is trying to go out, but atmosphere is not allowing it to come out of it. Correct or not? If I keep on giving energy, what happens to energy of that gas? What happens to pressure of that bubble? At some point, it shows pressure equal to atmospheric pressure. Then what happens? It will come to the surface. Even if it dominates a little, then what happens? It will escape. When it escapes, what happens to quantity of liquid? If I keep on giving energy, means liquid keep on continuing into vapor. Now tell me, what is boiling point? The temperature at which this minimum becomes equal to, that's what I have written. temperature at which PA becomes equal to P external. Right, sir? Respond. Yes or no? Now, by some means, if I keep on increasing it, if I am increasing P atmosphere or P external, then what happens to P of gas? What should happen to P of gas to convert into vapor? It should increase. How I am going to increase it? By providing more heat. Means what happens to boiling point of water? Increases or not? I need to provide more heat energy in order to make this to escape. Means if I keep on increasing P external, what happens to the temperature I need to provide to convert this liquid into vapor should also increase. That's why instead of writing this, I am making one statement. As P external increases, as P external increases, what happened? Yes, ma'am. Silent pause now. As P external increases, what happened? I need more temperature in order to make P of gas become equal to P atmosphere. Means boiling point of liquid increases. Correct, sir? Respond, sir. Any questions, sir, in it? Yes or no? Now, one more thing. This is Earth surface. This is Earth surface. You are standing here. Right? And this is the layer of atmosphere. This is all atmosphere. Air. All this weight of atmosphere will be pulled towards the center of Earth. So if you are standing here, what atmosphere is trying to do to you? It is trying to crush you down. Correct? Correct or not? That's why astronauts who was living in that space station, always their bones grow taller than those who are living on Earth. Correct or not? Therefore, their bone density will change. Right? Correct or not? So, okay, leave it. That is a part. Now, I am standing on a lift which can move up to infinite height. Assume. If I am moving from here to here, what happens to the amount of air above me? Decreased. Correct? Huh? So as I keep on moving upward, what about the force exerted by atmosphere on me? Decreases. Force acting per unit area is called? So pressure exerted on me, decreasing. Means P of atmosphere is decreasing. Means P external is decreasing. If a P external decreases, what happens to boiling point of water? Means if water boils here at approximately 100 degrees centigrade, here definitely water boils here at 99.6 degrees centigrade or not. If I move further, it may boil at minus 23 degrees centigrade. Yes or no? And if I keep on moving upward, what happens to P external? Keep on decreasing. Have you done any air travel through Air India flights? Right? So in front of your screen, there will be a display. Outside temperature is minus 35 degrees centigrade, but you are seeing clouds. What is cloud? Water vapor only, na? Sir, yet how water vapor will be in gaseous form at minus 35? Reason? What happened to atmospheric pressure there? Is so low, water will boil now yet. Even at zero also, water will convert into. Are you able to understand? Any questions in it? Now, due to air currents, due to any atmospheric disturbances, suddenly here pressure suddenly raised. If a P external, P of atmosphere suddenly raised, what happens to boiling point of water? That means at minus 23, it is no longer exist as vapor. Now it converts into rainfall happens. Correct or not? That's what we will say. When we will rainfall happens in two cases. When pressure becomes low or when pressure becomes high. Have you studied it? Or, at least in news you might have heard. Alpa Pedanam. Alpa means low. Pedanam means pressure. At low pressure. So when pressure falls suddenly, what happens? If you are standing here, if a pressure got decreased suddenly here, what happens to all clouds from different regions? Comes here. If all clouds comes to one place, what happens? They will make collisions. If they make collisions, charge distribution happens. Or static electricity, when cloud is moving, it will have friction with air or not. So static electricity has been developed. Another cloud molecule also comes closer. If they have opposite charges, right? Lightning happens. Due to charge exchanges, immediately water molecules will change the phase. Rainfall happens. Understood or not? Possible or not? Now, second, if a pressure rises also, all gas should convert into liquid, then also rainfall happens. Is it clear? So, now listen. I am handling a beaker of water in my hand. I'm having a beaker of water in my hand, right? And if I'm standing in an infinite long lift, right? So as I am keep on moving upward, what happens to the quantity of water in my hand in that beaker? Because it will start boiling. Reason? Reason? Pressure decreases. Right? Now listen. If I want to evaporate liquid, do I need to provide heat or no need? No need. Just if I create vacuum, what happens? Or if I keep on decreasing pressure, I have taken a beaker of water inside a vessel. I have taken a liquid inside a vessel and I have connected this to a vacuum pump. What vacuum pump will do? It will keep on decreasing pressure inside that beaker, right? Then what happens to boiling point of the liquid? Keep on decreasing. At certain pressure, obviously that liquid starts boiling. Right? Listen, sir, yes or no? Now tell me, water boils at 100 degrees centigrade. Right statement or wrong statement? Water boils at 100 degrees centigrade. Yes or no?
No, sir.
Huh? If
No,
you
sir.
don't mention pressure, it is wrong. Water boils at 100 degrees centigrade if and only if P external is equal to 1 atmosphere. If a P external is decreasing from 1 atmosphere, boiling point of water also will keep on decreasing. If a P external approaches 0, boiling point of water approaches to -5, -10, -20, -30, -40, it can go up to -272.999. Because according to Kelvin, it is impossible to reach -273 Kelvin. Right? Sorry, -273 degrees centigrade means 0 Kelvin is the lowest temperature possible. Understood, sir? Any questions, sir, in it? Correct or not? No. Again, I am plotting the graph. I am taking this graph. This is the graph for ideal solutions, right? Correct? Huh? This is the graph for ideal solutions. So in this, I am removing all this nonsense stuff. Or I will do one thing. You try to understand, man. Listen carefully. and understand. Instead of plotting a graph between vapor pressure versus mole fraction, now I am plotting a graph between boiling point versus mole fraction. Now tell me how the graph is. How the graph is. The vapor pressure is high for B. Means B can convert into vapor readily. Then what about its boiling point? Low. Correct? Means now this becomes boiling point of. I will do one thing. I will move that a little upward. So I call this point as TB of B. Will you understand, sir? Now I am writing here TB of A. Will you understand why I have written that? Because for all cases, what I made an assumption. What that assumption is? Vapor pressure of B is more. Vapor pressure of B is more means its boiling point will be low. Correct? Response, sir. Now tell me what this line indicates. What this line indicates. What this line indicates, man? Vapor pressure of solution. Correct? This line indicates vapor pressure of solution or not? This line indicates, remove all this stuff. What that line indicates? Vapor pressure of solution or not? Define vapor pressure. What is vapor pressure means? Pressure exerted by vapor on surface of liquid at equilibrium. Correct or not? While we are defining vapor pressure, what we discussed? Pressure exerted by liquid, vapor on the surface of its liquid at equilibrium. Means this line indicates pressure at equilibrium. Correct? That means what about this line indicates? Boiling point at equilibrium. Correct, sir? This indicates pressure at equilibrium. Means this line indicates boiling point at equilibrium. What do you mean by the equilibrium? There must be liquid as well as vapor. So what this line indicates? There exists equilibrium between liquid and vapor. So vapor is trying to convert into liquid. Liquid is also trying to convert into vapor. Both are happening simultaneously at this line. If I move above that line a little, what happens? What about a line? Or what about this curve? What this curve indicates now? What is the meaning of this curve?
Negative deviation also.
Above that curve, what you will see? Liquid or only vapor? Liquid, why? Boiling point is high. Means I have taken more temperature, right? Okay. Now I am writing this as temperature. So I am providing temperatures higher. At higher temperatures, whether you find that in liquid phase or gaseous phase. Again, I am repeating. On this line, on the dotted line, there exists equilibrium. Means there exists liquid as well as vapor, both. Now I am drawing one line above that, right? Above that line, temperature is more than what I expected. I am providing more temperature. That is the meaning of it. Now, this line indicates at higher temperatures than this equilibrium point. Correct? So at higher temperatures than the equilibrium temperature, whether that is found in liquid state or vapor phase. So above this curve, all will exist as only vapors exist. Correct or not? Yes or no? No. Same way, below this curve, what you will find? Below this curve, what you will find always? liquids. You will find only liquids, liquid state below this curve, vapor phase above that curve. Right? In between these two solid lines, what you will do? What you will do? Between these two curves, liquid is trying to convert into vapor, reaches equilibrium. Above that point, amount of vapor is more, liquid keep on decreasing. The moment I reach this point, fully vapor, if I keep on going away, everything keep on existing in vapor and temperature of vapor keep on increasing. Correct or? Response, sir. Yes or no? Correct? I have drawn a straight line, means whether I am studying about ideal or non-ideal solution. Ideal. So this is the graph for what type of solutions, sir? Ideal solutions. But this is not vapor pressure graph. This is the graph for boiling point. Correct? Any questions? Perfectly clear or not? Response, sir. Yes or no? Now observe very carefully, sir. So I have taken two liquids now. One liquid is having one boiling point, another liquid is having another boiling point, right? So I have taken two liquids. Let me consider TBA is boiling point of liquid A. TBB is boiling point of liquid B. Right? Now, according to the graph, what we have assumed? According to graph, tell me, sir, what you assumed? TB of A is greater than TB of B. Why TB of A is greater than TB of B, sir? Because vapor pressure of A is greater than okay, B is greater than A. So that is PB naught is greater than PA naught. Will you understand, sir? Correct or not? No confusions, no? The vapor pressure of B is more. Therefore, its boiling point is low. Correct? No questions, no? Now, very good, sir. Now listen very carefully, sir. I have taken one point here, sir. I have taken one point here. Right? What this point indicates? Pure A or pure B or solution? Because A is almost close to 1, but not equal to 1. Means more amount of A I have taken, less amount of B I have taken. Correct? Huh? The meaning of this is A quantity is more, B quantity is less. Right? So this is the composition of that mixture solution. Now I keep on increasing the temperature of the solution till I reach this point. Till I reach this point, that solution exists in liquid phase only. Correct? Huh? Now, after reaching this point, then what happened? That liquid will start converting into vapor. Now I stopped heating it. I kept the temperature as constant. I raised the temperature of that mixture solution up to that point and I stopped that and I am maintaining the temperature as constant. Now, what is the temperature of vapor generated on the surface of it? Will be same or will be different? Same only. Array, I have raised the temperature of that up to that point and I am keeping that as constant. Now, then whatever the vapor generated above it, its vapor temperature also should remain same or not? Correct? Response, sir. So, Means can I say this is the composition of vapor which is generated above it? Reason? The temperature of vapor should be same as the temperature of liquid means. So composition of vapor at the temperature must be equal to this or not? Right? So for your convenience, for your understanding, I am increasing the slope of that curve. I am increasing the slope, sir, so that you will understand more easily. Above this, you will find only vapor. Below this, you will find only liquid. Now I have taken this composition. At this composition, I keep on increasing temperature and I kept this temperature constant. This is the constant temperature. That is the temperature of the liquid now. So above the liquid, there will be vapor. Temperature of the vapor also should remain same. So temperature of the vapor also should remain same means this point should be same now. Means this should be the composition of vapor generated above it. Correct or not? Now I have collected those vapors into another beaker. Right? Whatever the vapor generated now, I collected those vapors into another beaker. I am decreasing the temperature of those vapors. What happened? If I decrease the temperature of those vapors will condense. Now this will be the composition of those vapors or not? Response, sir. Now again, I am raising the temperature of composition of those vapors up to this point. And I kept the temperature constant. Then this will be the composition of vapor generated above it. Now I have collected those vapors again and I am condensing it. Again, I am raising the temperature of that up to this and I will keep that constant. Then above that also again, vapors will generate. What you have observed based upon this observation? What you have observed based upon this? Yes, sir. No, okay, boiling point decreases. Composition of liquid is also changing. If I do this process repeatedly, after certain point, what vapors I will find? I will find vapors of pure B. Correct or not? Means I am going to separate liquid A and liquid B by using this method. What we call it as distillation. What we do during distillation? If I mix ethanol and water, ethanol boils at 80, water boils at 100. Correct? If I keep on heating it up to 90, at 90 degrees centigrade, if I leave them, which will convert into vapor readily. Water also will evaporate, but composition of ethanol is more, water will be less. So now I have collected those vapors. I have condensed them. Now I have got a different liquid now. Correct or not? First case, whatever is left, that I call it as residue. This I call it as a distillate. During distillation, ethanol got evaporated readily than water. So more ethanol vapors are there, less water vapors are there. I call this as distillate. Whatever is left at the bottom, I call it as residue. Now I separated the distillate into another beaker. I kept residue separately. Now tell me, in this residue, which is more in quantity? Water. Right? In distillate, which is more in quantity? Ethanol. Now I condense it. Again, I am doing the process. Now again, I am getting distillate and residue. Now tell me, what is composition of ethanol in the distillate again? Enhanced. If I do this process repeatedly again and again and again, after a certain point, what happens? Percentage of ethanol keep on enhancing, it reaches to 95%, 96%, yes or no? Means what I am trying to do. By distillation process, I am going to separate both the liquids. Yes or no? Right? Response, sir. So that's what I am writing. On distillation, on distillation, what happens on distillation? On distillation, distillate. Will you understand what do you mean by distillate? Okay, on distillation, residue gets enhanced with. Residue gets enhanced with. With what it is getting enhanced? Enhanced with liquid with a high boiling point. Correct or not? Right. Response, sir. Yes or no? A liquid which is having low boiling point that will convert into vapor readily. So which is having high boiling point that will be present in residue only, na? Right? So residue gets enhanced with liquid with liquid of high boiling point. Whereas distillate, melting, not melting point, boiling point. Whereas distillate gets enhanced with vapors of liquid, enhanced with vapors of liquid liquid having low boiling point. Accepted or not? Right? That is composition of distillate differ from residue. Accepted or sir? Composition of distillate differ from residue. Accepted or not, sir? Respond. Now tell me, do this distillate and this residue, which is having higher boiling point? Do the distillate or residue, which will have higher boiling point? Residue, right? Correct or not? Distillate's boiling point keep on decreasing now. Reason? And it keep on decreasing and approaches to. No, not zero. It approaches to TB, boiling point of B. Residues, boiling point slowly increases and approaches to boiling point of A. Correct, sir? Any questions in it? Right? Any questions? So, composition of distillate decreases and approaches boiling point of low boiling liquid. Correct? Boiling point of liquid with lower boiling point. In case of residue, what you understood, man? We are talking about boiling point, na? Here I have to write boiling point decreases and approaches boiling point of liquid having lower boiling point, correct, sir? And boiling point of residue enhances and approaches boiling point of liquid having higher boiling point. Any questions, sir? Right? On separating the distillate, right? And distillation is repeated. On separating the distillate and distillation is repeated again and again. What happens, sir? Again and again. What happens? To separate both the liquids from the given composition. Accepted or not, sir? Any questions, sir, in it? If you understand this, now I will start the game. We have any questions till now? Right? This idea is enough to start the game. If you understand the graph, so many numericals you can solve. Just if you understand it, that is enough. Right? Any questions regarding this? Do you understand this idea or not? Understood, na? No doubts, na? Say yes or no. No doubts. Correct? Akka. Very, very good. So this is also boiling point of ideal solution or non-ideal solution? Ideal only, na? Oh, something I have done. Response, sir. Right? This is also composition of ideal solutions, right? Now I am coming back to our study. Now, sir. Now we need to study about non-ideal. Right? What this curve indicates? What this curve indicates, man? What this curve indicates? I don't want remaining all nonsense. I want only this curve. What this curve indicates? Vapor pressure of solution, yet equilibrium. Correct? That curve indicates vapor pressure of solution at equilibrium. Correct? Yes or no? Say something. Correct? Now, very beautiful concept, sir. See the beauty of it. See, sir, what I'm doing. I'm removing this word vapor pressure and I'm writing the word boiling point. Now tell me, sir, how the graph is. Remaining all are same. Tell me how the graph will be. Temperature versus mole fraction graph. How the graph is? This is vapor pressure graph, man. Vapor pressure of towards B, hump is there. Towards B, hump is there, right? If I plot a graph for boiling point towards B, you will find depth or hump. Tip, correct? Yes or no? So vapor pressure of B is high means boiling point of B will be low. This is boiling point of B. This is boiling point of A. Correct, sir? Now, this will be the graph. The dotted line indicates equilibrium. Yes or no? Any confusion? Simple, na? If I move a point above that curve, I will find only vapors. If I move a little below that curve, I will find only liquids. Now, if I identify the points at which only vapors are present, if I identify the points at which only liquids are present, right? That graph will be like this. Observe these graphs carefully, sir. Above this curve, what you will find? Only vapors. Below that curve, what you will find? Only liquid. If you observe this graph carefully, at some point, what you will find? Both becomes equal. We call that point, that composition is called as azeotrope. What we call that as? Azeotrope. Azeotrope is also called as constant boiling liquid. Azeotrope is called constant boiling liquid. Why I call it as constant boiling means what is its composition in liquid phase and what is its composition in vapor phase. Observe that point. Both liquid and vapor phases compositions became same. That's why it is called constant boiling liquid. That is called azeotrope. Azeotrope, also called as constant boiling liquid. Any questions, sir? In the same way, I am plotting graph for this side, sir. Are you able to understand what I am talking about? Any confusion? Is it necessary this word according to Raoult's law? Nothing, na? Not required, na? I am adjusting this a little left so that that graph also comes on to same line, same page. Response, sir. Do you have, if you have any confusions, you need to let me know immediately. Do you have any confusions? Say something, yes or no? Yes, sir. What confusion, sir? Yes. Tell me where you are finding difficulty. Now tell me the graph in this case. You tell me what confusion you are facing and tell me about this graph. Both. Now tell, sir, how the graph will be, sir. How the graph will be? Observe vapor pressure graph and boiling point graph. How the graph will be? Graph will be something like this. We accept. Then this curve will be like this. Then what about this point? What about this point, sir? Azeotrope composition. Below this, you will find only liquid. Above this, you will find only vapor. Right? Now, before going further, yes, sir.
How will you plot those?
I have not plotted, man. Who said I plotted? Huh? I have never plotted. That's why I'm showing. I will show you who plotted. I never plotted. Huh? I have shown just who plotted that. That's all. Wait. P.W. Atkins. Right. Right. Now, boiling point can be measured experimentally or not? Right? So just that graph is nothing but measuring boiling point value composition. Boiling point value composition. I will take pure A. I will add 1 drop of B. Measure boiling point. Plot. 1 more drop. Boiling point. Graph. Plot. Right? You keep on adding 1 drop and you keep on keeping in the graph 1 dot. Correct? And you join all the dots. When you join all the dots, you will get the graph. Correct? So this is the graph only, right? Now I want to show you. Where is that graph, man? Observe, sir. What I told you about T versus composition. Have you seen this graph or not? Below this curve, below this bottom curve, you will find only above that bottom curve. So what is that? One indicates first distillation process. Then I will collect that vapors, condense. Again, second time distillation, condense. Third time distillation, condense. Fourth time. If I keep on doing n number of distillations, finally I will reach pure B. Means that's how I am going to separate liquid A from liquid B. Correct? Huh? Say something. Now observe the graph. This is not my graph, sir. This is the graph they have plotted by doing experiment. Whether we have seen the same graphs or not. Say something. Correct? So do I have plotted the graph or the graphs are plotted experimentally? I gave only theoretical explanation for it. That's all. Clear, sir? Have you got these two type of graphs or not? Now tell me. First type of graph shows what type of solutions? Positive deviation or negative deviation? Which type of solution shows this type of graph? Negative deviation. Why? Negative deviation means boiling points are high. Correct? Huh? Sir, I will show that. This is negative deviation or not? Right? Their vapor pressures are low. Therefore, boiling points are high. Right? We call such azeotropes as maximum boiling azeotropes. What we call them as? These azeotropes are called as maximum boiling azeotrope. This is the composition of maximum boiling azeotrope. Accepted. Now tell me, what about this one? This is the composition of what? Composition of minimum boiling azeotrope. Now tell me, what type of solutions show maximum boiling azeotrope? Solutions showing negative deviation from Raoult's law will form maximum boiling azeotrope. Observe this graph carefully. Yet this particular composition, boiling point of that composition is more than the boiling points of individual liquids. That's why it is called. Are you able to understand why it is called maximum? Means this temperature, that boiling point is greater than individual boiling points. It is more than A as well as B boiling point. Now see the first graph. This boiling point is less than both. That's why it is called minimum boiling agent. Right? Understood? Response, sir. Response, sir. Clear? I am going to show the data also, experimental data also. Don't think much about this here. What this indicates, A4 prime. What is this A4? At A4, what you will find? Only liquid. A4 prime is the vapor, composition of vapor obtained above that liquid at the same temperature. Correct or not? At the same temperature. Respond. Yes or no? I say something, man. Now I am going to show the table. Oh, they have not given any table, huh? They have to give the table, no? Azeotropes table they have not given me. Don't worry, I will show you the table. I think at the end of this book you will find the table. Directly I will go to the end of the book. Oh, not there, huh? Every time I keep on saying don't trust me. That's why I will show you what they have found practically, for which I have given theoretical explanation on. Experiments that done by them. I am saying why they got that graph, right? And they found experimentally. Experimental data we are going to take and we are going to come to a conclusion. Based upon conclusion, we will start solving numerics. Want to show the table, man. 1 minute. Wherever you find negative deviation, immediately tell me. Or positive deviation. This is option. Arrhenius parameters. Second order kinetics, chemical kinetics. This is second order, first order. Diffusion coefficients. Ionic mobility, Debye-Hekuland-Sager equation. Okay, ionic conductance, electrochemistry, transportation number, susceptibilities, lattice energies, ionic radius, intrinsic fractional coefficients, diffusion coefficient, radius of gyration, Dipole moment and polarity is okay. Hyperbolic coupling, resonance, absorption. Stop talking, please. These are all reduction potential values. Now, freezing point, boiling. Remind me about this also. This also we are going to see the table also, right? Henry's law constants. Have we discussed this or not? Henry's law constant for gases, for methane, carbon dioxide in water, H2 in water. KH values, man. Observe the units. Kilopascal, kg per mole. Response, sir. Now tell me what is the formula they have used to give these values. With P naught into mole fraction. If it is P naught into mole fraction, what are the units of KH? Only kilopascal. They have given it as kilopascal kg per mole. Kg per mole. Mole per kg is molality, man. Right? Molality is mole per kg. If I bring that mole per kg to this side, kg per mole. Correct? So I am getting kg per mole. Means what is the formula? Huh? KH into molality. Huh? KH into molality equal to solubility. Correct? Huh? No. Pressure is equal to KH into molality. Yes or no? Pressure is equal to KH into molality. Yes or no? Correct or not? So that is the unit. What I told you about Henry's constant, it is an empirical relation. That's why based upon the expression, units of KH will change. So while if you are solving a numerical, you need to first check units of KH. Different people, different scientists will give different data. Accordingly, here they give this data. So accordingly, I will change the formula. These are all normal boiling points, sir. Right? Means we are close to the data. Entropies, Joule-Thomson expansion coefficient. Maybe they have not given or what? Enthalpy, Gibbs free energies, peak capacities. Okay. So much data they have given, but what we require they have not given. Or they have not given, man. You are bad luck. What I will do? I will close this. I will show the data from my previous notes. That is the best option I have. Now see, sir. My last year's notes. I will start from the beginning. Have we discussed anything about this solubility of gas and liquids? Discussion done or not? Henry's law discussion done or not? This table is done or not? Solubility of liquids in liquids. Definition about vapor pressure done or not? Then this is done. Examples of done. Liquid compositions. Ideal, non-ideal. Done or not? Positive deviation, negative deviation. Done or not? These are two graphs. Done or not? Corresponding examples. We will discuss those examples. Right? Then we have played some mathematical games. After that, distillation. This process is done or not? Then minimum boiling azeotrope, maximum boiling azeotrope. Done or not? What is azeotrope? Constant boiling liquid. Composition remains same in vapor phase as well as in liquid phase at a particular composition. We call it as azeotropic mixture, right? Examples. See this example. Percentage weight by weight of means percentage composition of acetic acid. Percentage composition of toluene. Boiling point of acetic acid is 118.5 degrees. Boiling point of toluene is 110, right? Boiling point of azeotrope. What is this azeotrope? 105 means it is less than both. Therefore, what type of mixture these two will form? Minimum boiling azeotrope means positive deviation from Raoult's law. Correct or not? Now, means is it possible to separate acetic acid and toluene by distillation method or not? Is it possible to separate acetic acid and toluene by using distillation? Yes or no? No. Reason, this is the graph, right? Because of this graph, what happened? When compositions keep on changing, we will reach always this point, right? After reaching this point, what is composition liquid and vapor? If they remain same, how are we going to separate? Liquid and vapor composition is same, correct? So if I separate that vapor and if I condense and if I boil again, what happens again? Same. Means distillation process fails in case of azeotropes. So in azeotropes, distillation is not suitable. Is it clear? Right? If I increase temperature, all that liquid will convert to vapor only. Observe this point. What this point indicates, I will come to this. What this point indicates. At this point, liquid and vapor both have same composition. So after reaching this point, whatever temperature I apply, total liquid converted into vapor, but percentage of liquid, percentage of vapor remains the same only, na? Mole fraction of A in liquid, mole fraction of A in vapor, mole fraction of B in liquid, mole fraction of B in vapor, both are same. Then how I am going to separate them? If I start from left, again I will reach this point and I will stop. If I start from right, again I will reach that point and I will stop. Means in case of positive deviation, negative deviation solutions which do not obey Raoult's law, when I do distillation process, always I will reach azeotropic mixture and I will be stopped there. Then, sir, how I am going to separate them? Their physical method of process is failed. We will now go with chemicals. Right? So what I will do now? In this room, I have kept a sulfuric acid bucket at one corner. Ethyl alcohol plus water mixture bucket at that corner. One drum filled with ethyl alcohol plus water. I will keep at that corner. At this corner, I will keep sulfuric acid bucket. Okay, calcium chloride bucket or P4O10 bucket at this one, right? What happens? What is ethyl alcohol plus water composition? Positive or negative deviation? Ethyl alcohol plus water. Again, I will show. Check ethyl alcohol plus water. Where is it? Here. Ethanol plus water. Ethanol boiling point 78.4. Water boiling point 100. But both will boil at 78.1. Positive deviation from Raoult's law. That's why it is a minimum boiling azeotrope. Correct or not? So up to 95.5% ethanol and 4.5% water, you can separate them by using distillation. After reaching that point, whatever distillation methods you do, they will not get separated. It will become constant. So that composition we will keep at that corner. And I have kept anhydrous calcium chloride here. What anhydrous calcium chloride will do? Absorbs moisture from atmosphere. Then what happens to vapor content in air? Then what air will do? Absorb water from ethanol plus water composition. Right? Are you able to understand? That's how I am going to remove moisture from, not by heating, not by distillation. Are you able to understand? By using vapor pressure idea, we are going to separate. Now it reaches 100%, then what we call it as absolute spirit. Correct or not? Now I will reach up to 99.99% or 100%. Distillation phase. Clear? But it is a time-taking process, slow process. Distillation is easy process. So via distillation, I will reach up to this point. After that, slow process I will follow to get 100%. Clear? Any questions, sir? Yes, yes. KGO2? What you are doing? Array. It is called constant boiling liquid. If I decrease pressure, what happens to boiling point of that constant boiling liquid? Decreases. So its boiling point decrease, but total thing will evaporate, na? Are you able to understand? Right? Its a composition remains the same in liquid and vapor. So total thing will evaporate. Its composition will not change. Percentage of A, percentage of B will never change. Understood? Any questions further?
Sir,
Yes, sir.
sir, after attaining the azeotrope, can you explain the process, sir, how to separate out?
I will follow different method, not by distillation method. Right? We will follow chemical
Okay.
methods, or by adding benzene, or by mixing anhydrous calcium chloride, or by using concentrated sulfuric acid. By playing with atmospheric conditions, I am going to separate them, not by distillation. Clear?
Okay, sir.
Yes. Via? If it is perfectly ideal solution, you can separate. That's what I am showing. Right? Now the question is whether perfect ideal solutions available or not. That is the question. If available, they can be separated 100%. Clear? Any questions, sir, further? Right? Just I will copy paste this table, sir. Will you understand now? Idea. Any questions? Response, sir. Do you have any questions in this? Right. Examples also I will copy paste here. Right? Now I will start playing with equations. All right. Now my favorite part. Right? Listen, sir. Note point 1. Every point is JEE advanced question. Every point they will give minimum 5 to 10 questions numerically. Every point from hereafter. Till now theory. Right? What is Raoult's law, sir? According to Raoult's law. What is it, Raoult's law, sir? Say something. P is equal to PA naught into XA plus PB naught into XB. Or I will write PA is equal to PA naught into XA, PB equal to PB naught into XB. Correct, sir? What is PA, PB? Vapor pressures of A, vapor pressure of B, or partial pressure of A, partial pressure of B. So I will write vapor pressure of A vapor pressure of B. This is, what is this? Vapor pressure of solution. Is it theoretical or experimental? Experimental. Theoretical value is this. Experimental value is this. Both are equal means ideal. Means they are obeying Raoult's law. Correct? Response, sir. This indicates theoretical value. This indicates experimental value. Both are equal. If both are equal, you can call this as theoretical or experimental, your wish. That's why I'm writing vapor pressure of solution. Now, what is this XA and what is XB? XA comma XBR. What are they? Mole fractions of right A and B, mole fractions of A and B in liquid phase. Correct, sir? When they are in liquids, in liquid space, what is mole fraction of A? What is mole fraction of B? What are PA naught, PB naught? They are vapor pressures of pure liquids. Correct? These are vapor pressures of pure liquids. Accepted or not, sir? Mole fractions of components in liquid phase. Don't get confused, man. Any questions in it? Now, second point I'm writing. According to Dalton's law. What is Dalton's law? According to Dalton's law. Tell sir. What is Dalton's law? P is equal to PA plus PB. Correct? Where PA equal to YA into P total. YA comma YB are mole fraction of gases. And Dalton's law is applicable for mixture of gases or not? Mixture of non-reacting gases. Raoult's law is applicable for mixture of non-reacting liquids. This is applicable for mixture of non-reacting gases. These are mole fraction of components in vapor phase. Do you have any doubts regarding this? Do you have any doubt in this? I have taken carbon dioxide gas, nitrogen gas, whether these two react or not, carbon dioxide, nitrogen. Don't react now, so I mixed them. If the amount of nitrogen is more, then pressure exerted by nitrogen is more, right? So that's what I'm writing. Pressure exerted by nitrogen is directly proportional to mole fraction of nitrogen in air. Correct? Bring that P to this side. PA by P is nothing but mole fraction of nitrogen. And partial pressure of nitrogen by total pressure is nothing but equal to number of moles of nitrogen by total number of moles. Correct or not? Any questions? Clear or not? Now, third point. Can I write P is equal to PA naught minus PB naught into XA plus PB naught. Can I write it, sir? P is equal to PA naught minus PB naught into XA plus PB naught. Can I write it or not? We know XA plus XB equal to 1 or not? XA plus XB, mole fraction of component A plus mole fraction of component B. If I add both fractions, it becomes equal to 1. Correct? So what is XB can be written as 1 minus XA. Substitute that XB here. Therefore, what happens? P equal to PA naught into XA plus PB naught into 1 minus XA. Accepted? Expand. P is equal to PA naught XA plus PB naught minus PB naught into XA. Take XA common. What do you get? PA naught minus PB naught into XA plus PB naught. Correct? So I don't want this waste fellow now. remove. Done? Any questions in it? Very good. Point number 4. Listen carefully, sir. I am giving derivation. This derivation also important. That's why I'm writing. XA plus XB equal to 1. You know it. Instead of XA, can I write PA upon PA naught? Instead of XA, can I write PA upon PA naught? From this equation, first equation. Right? So I'm writing it. So PA upon PA naught plus PB upon PB naught is equal to 1. Correct? That applies. According to Dalton's law, what is PA? YA into P. So instead of PA, I am writing that. YA into P upon PA naught plus YB into P upon PB naught is equal to 1. Therefore, YA upon PA naught plus YB upon PB naught is equal to 1 upon P. Accepted, sir? Say something. Any questions in this? Do you have any questions in it? Right? So this is the equation I will follow when there exist equilibrium between liquid phase and vapor phase. Any questions, sir? You have any questions in it? And I am using vapor pressures or not? Right? I am using vapor pressure means always liquid and vapor both should exist. Both are existing means they should exist in equilibrium only. That's what I am writing. There exists equilibrium between vapor phase and liquid phase. Then I will follow this equation. Anything wrong? Point number 5. Point number 5. I am taking this equation. P is equal to PA naught minus PB naught into XA plus PB naught. This is the equation. I am taking this equation. In this equation, instead of P, can I write PA upon YA? In this equation, instead of P, can I write PA upon YA? Can I write it? Response, sir. Instead of P, I am writing PA upon YA. Nothing wrong now. So what will be the equation now? PA upon YA equal to PA upon YA equal to what you will get? PA naught minus PB naught into XA plus PB naught. Correct? Instead of PA, can I write PA naught into XA again? Can I write it? So I am writing it. Instead of PA, I am writing PA naught into XA. Is there anything wrong, sir? Is there anything wrong? Right? I am bringing that PA naught XA to right side. What happens to this equation now? 1 upon YA equal to. I am bringing this PA naught into XA to the right side. What happened? What is YA? What is XA? What, sir? Huh? Correct? Liquid I have mixed two liquids. Some vapor is there. In vapor, A is there, B is there. In liquid also, A is there, B is there. What is the composition of A and B in liquid means XA, XB. What is the composition of A and B in vapors means YA, Y. Both are, all the four are present. Clear? Any questions? Right? Now, what is 1 upon YA equal? Bring that PA naught XA to that side. Here, denominator PA naught XA, here also PA naught XA. So, can I write this as PA naught minus PB naught upon PA naught plus PB naught upon PA naught into 1 upon XA. Correct, sir? Straight line equation. Y equal to mx plus c. Yes or no? Respond, sir. Old JEE advanced question. When you plot a graph between 1 upon YA versus 1 upon XA, intercept will be. If you plot a graph between 1 upon YA versus 1 upon XA, what will be the intercept? PA naught minus PB naught upon PA naught. So I am plotting a graph. So I am plotting a graph between 1 upon YA, 1 upon XA. I plotted a graph. Right? Correct, sir? 1 upon YA, 1 upon XA. I plotted a graph. Now tell me how the graph is. Straight line, huh? Passing through origin, or it has to make any intercept. Intercept positive or negative? Positive, huh? So can I plot a graph like this? Say something. What is this value? PA naught minus PB naught upon PA naught. Response, sir. What is the slope? PB naught upon PA naught. Right? Now, similarly, what is 1 upon YB equal to? What is 1 upon YB equal to? PB naught minus PA naught upon PB naught plus PA naught upon PB naught into 1 upon XB. Accepted? I say something. Yes or no? Or if you want, do one thing. You want to plot graph between YB and XB. Means instead of P, what you will write? Instead of this P, what you will write? Instead of P, PB upon YB you will write. Instead of PB, PB naught into XB. So PB naught into XB upon YB. Plot the graph. Over. Response, sir. Similarly, what will be the graph for 1 upon XA equal to? This is 1 upon YA equal to. I want 1 upon XA means bring everything to the right side, not to the left side. From first equation, bring everything to the left side. Then what you will get? 1 upon XA equal to PB naught minus PA naught upon PB naught plus PB naught upon PA naught upon PB naught into 1 upon YA. What you observed? What you have observed? Or if you want, check it. Bring everything to this side and check the equation, man. Then what you have observed? Observe these two equations carefully. Intercept and slope
intercept are same.
are same for graphs of 1 upon YB versus 1 upon XB, 1 upon XA versus 1 upon YA. Right? On y-axis 1 upon YB, x-axis 1 upon XB. Slope and intercept is same as If y-axis is 1 upon xa and x-axis is 1 upon y. Similarly, what about 1 upon xb equal to? PA naught minus PB naught upon PA naught plus PB naught upon PA naught into 1 upon YB. 4 types of graphs, 4 types of equations. Right? Now, the most beautiful part comes. Point number 6. 99.9999% people will fail. The condition which I am going to do. Right? Out of 10,000 people, 1 person will know this. Right? Listen very carefully. Sometimes they will give you a question in this way. Listen, sir. I have taken A, liquid B. I mixed both of them. Now, some amount of moles, some moles of A will convert into vapor. Some moles of A will be left in liquid state. Right? If number of moles of A in liquid is some X, number of moles of A in vapor is Y. If X becomes equal to Y, understand this? What is the meaning of it? The amount of A in liquid phase becomes equal to amount of A in vapor phase. Correct? That's what now I am saying. X becomes equal to Y. Right? Or can I say that as YA minus XA is minimum? Or instead of saying 0, I am saying minimum. Or approaches to 0, man. Correct? Correct or not? I will take that as mod. Why I am taking it as mod, sir? Mod YA minus XA. Why I am taking it as mod, sir? Either YA minus XA is minimum or XA minus YA is minimum. Both should be. Minimum means difference only, na? Should approach, it should not be negative or positive. It should be close to 0. Correct? Or minima, maxima. Yes, sir. So mod YA minus XA is either minima or maxima. Then total P equal to root PA naught into PB naught. So simple. If a mod YA minus XA is a minima or maxima, then total pressure P equal to root of PA naught into PB naught. Right? Then what is XA equal to? Again, I am saying, I am repeating the question again. Listen. I have mixed liquid A, liquid B, both. Right? Assume that some amount of A got evaporated, some amount of A present in liquid. In the same way, some amount of B will get evaporated, some amount of B will be in liquid state. Right? If a number of moles of A in liquid is X, number of moles of A in vapor is Y. If I am saying X and Y are approximately same, means what about Y minus X value? Minimum. Or X minus Y value? Minimum. Correct? Respond, sir. Correct or not? That's what I am saying. Minimum. Sir, then why you have taken maxima? That also will. If difference between liquids of A and B is minimum means, what about difference between liquid and vapor of B? Right? I have taken A and B both liquids, man. In which both will evaporate to some extent. Now I am saying, in case of A, liquid and vapor phases difference is approximately 0. If this difference is 0, means what about B? B difference becomes maximum. Huh? That's what I am saying. Either minima condition is reached means for the other liquid, maxima condition is reached. So if they are asking maxima condition or minima condition, both remains similar. That's why I wrote either minima or max. Right? Now listen, sir. What I told you? Mod Ya minus Xa is either maxima or minima. Understood? These two people are present. Right? Right? If the quantity of this fellow is decreasing means what happens to quantity of this fellow? Both are present in the same box. Volume occupied by this fellow is decreasing means what about the volume occupied by this fellow? But both have to occupy total volume. What is the meaning of it? That's what I am saying. If A composition difference is decreasing means what about difference between B compositions? A has evaporated a little means what about B? Evaporated more. If B evaporated more means amount of B in vapor phase is more and amount of B in liquid phase is. That means what about difference between them? Maximum, no? Understood or not? Everything is mutually dependent, no? Any questions further? Shall I proceed? Means dou by dou x of Ya minus Xa must be equal to 0. The difference between them is 0 means slope of the curve must be. Difference between them is minimum means slope of the curve must be 0. Correct or not? Differentiation dy by dx must be equal to 0. Correct or sir? Any questions in it? Means instead of Ya, or you know this equation, na? P equal to Pa naught minus Pb naught into Xa plus Pb naught. Pa equal to Pa naught into Xa. Pa equal to Ya into P. These are the three equations we are using, correct? So instead of Ya, can I write Pa upon P minus Xa is minimum. Correct? Is minimum. Correct, sir? Instead of Pa, can I write Pa naught into Xa? So Pa naught into Xa minus P into Xa upon P is minima. Accepted, sir? Respond. Means dou by dou Xa of Pa naught Xa minus Pa naught minus Pb naught into Xa plus Pb naught into Xa upon Pa naught minus Pb naught into Xa plus Pb naught equal to 0. Accepted, sir? Apply U with U. Differentiation of U by V. What do you write? V into U dash minus U into V dash upon V square equal to 0. Submit. Apply. First, what I have to write? V into U dash, right? So this is V. So I am writing that. Pa naught minus Pb naught into Xa plus Pb naught into differentiation of this with respect to Xa. Then what you will get? Pa naught. Correct, sir? Here let it be multiplied. So I will write square here and here I will write Pb naught into Xa. Nothing wrong? Response, sir. Right? Now, what is differentiation of this? Minus 2 times of Pa naught minus Pb naught into Xa minus PB naught. Respond. Correct? Correct or not? So this whole thing minus PA naught into XA minus PA naught minus PB naught into XA square plus PB naught into XA into differentiation of this PA naught minus PB naught plus 0 whole divided by P square equal to, bring that to denominator to that side. Bring this negative to that side. Over. Sponsor. Done or not? Now separate the parameters. I am writing this as PA naught minus PB naught into XA plus PB naught. This one. Can I take PA naught minus PB naught common? Can I take PA naught minus PB naught common here? So PA naught minus PB naught into 1 minus 2XA. Accepted, sir? Correct or not? Is equal to this total equation. What do you write? PA naught XA minus PA naught XA square plus PB naught XA square minus PB naught XA, this whole thing into PA naught minus PB naught. Accepted, sir? Can I cancel this PA naught minus PB naught? Correct? Now multiply PA naught minus PB naught into XA plus PB naught minus 2XA times of this. So 2 into PA naught minus PB naught into XA square. Again minus 2 PB naught into XA is equal to this whole term. Respond, sir. Correct or not? Yes or no? Right? Now on both sides. Can I cancel any term? What I can take common here? Can I write PB naught minus PA naught into XA square? What is present here? Can I take anything common? Say something, man. Any confusion here till now? Differentiation you understood now? Differentiation, man. Understood or not? Check again, check again. Do differentiation. This is U, this is V. V into differentiation of U minus U into differentiation of V upon V square equal to 0. U into, sorry, V into U dash minus U into V dash upon V square equal to 0. If I bring V square to that side, then VU dash equal to UV dash or not? Right? Differentiation U by V rule means simply UV dash equal to VU dash. That's why it is called UV rule. Right? Yes or no? Right? If it is multiplied U into V, then what you will write? U into V dash plus V into U dash equal to 0. Means what you will write? VU dash equal to minus UV dash. Yes? Respond, sir. Any questions? You to find minima. Minima means the slope of the curve becomes 0. That's why I'm differentiating it. What, sir? Yes or no? Clear? whether this expansion is correct or not. Check. Whether that expansion is correct or not. Next step is answer. Within one step, you will get the answer. Up to here, check. I have taken that first term as it is. Sorry, denominator term as it is. This is the denominator term, V term. This is the denominator term. Right? I have taken the denominator term as it is. And differentiating this with respect to XA. Then what you will get? PA naught into XA differentiation is PA naught. Correct? Now, here this into XA square. What you will write? 2XA. So I am taking that constant into 2XA. Negative sign is there. So minus 2XA. Here also you will get negative sign or not? So what you will get? I missed the 2, huh? Hooray, here I missed the 2, man. Minus 2B naught. Huh? Hey. Where, man? Correct only. I have done correct only. Huh? This is minus PB naught into XA. Minus PB naught into XA means minus PB naught only, no? Differentiation. Over. Now, other part. I have taken numerator, U value this, correct? I have taken that U value as it is. Correct, sir? Into differentiation of denominator. This into differentiation of XA is 1. PB naught into constant. Differentiation of constant is 0. So PB naught term vanished. Right? Now I am expanding it by taking this common. First here I have taken what I have taken common? PA naught minus PB naught I have taken common. So what do you get? PA naught minus PB naught minus 2 times of PA naught minus PB naught into XA. So I am taking PA naught minus PB naught common. What do you get? 1 minus 2XA. Correct? Now this side term. As it is. I missed something, I think. Why I wrote negative here? Why I wrote my negative here? Minus multiplied, minus PA naught into XA square, minus of minus, plus PB naught into XA square, minus PB naught into XA. Remaining term as it is. Response, sir. So I cancel this PA naught minus PB naught term on that PA naught minus PB naught term on both sides. Yes or no? I am expanding the remaining total part. Expand the remaining total part. I multiplied this into 1. This into minus 2XA. Correct or not? This into 1. This into minus 2XA. So this into 1 as it is. This into minus 2XA, what you will write? Minus 2 into XA square into the term. Minus 2 into PB naught into XA term. Yes, sir. If we have one equation, if we plot a graph between y and x, right? Then what is dy by dx? Slope. Correct? Here I am plotting a graph between ya and xa. How I will get slope of that graph? dy by dx. That's what I wrote. D of that equation upon dx. I'm plotting it over. Then everything that given equation itself gets reversed. Instead of PA naught and PB naught, I need to exchange them. If I am writing it as with respect to YA, I will write this equation as PB naught into XB minus PB naught minus PA naught into XB square plus PA naught into XB. Then I will do it. Are you able to understand? Already that's why I proved it in the first step itself. When I am exchanging A and B terms, all the coefficients will change. In place of B, you will get A. In place of A, you will get B. If you want to differentiate with respect to Y, means you are saying it as, sir, D of that equation with respect to Y axis. Correct? Generally, we always do that with respect to x-axis. That's why I have taken that with respect to x-axis. Clear? Response, sir. Up to here, any questions? Whether this expansion is correct or not, check it. Whether that expansion is correct or not, check that. PA naught into XA minus PA naught square, PA naught into XA square, minus of minus plus PB naught into XA square, minus PB naught into XA, correct? So this. Expansion is correct. Now expand this term also. What do you get? PA naught XA minus PB naught into XA plus PB naught. Correct, sir? Minus two times of PA naught into XA square plus 2 times of PB naught into XA square minus 2 PB naught into XA is equal to PA naught XA minus PA naught XA square plus PB naught XA square minus PB naught into XA. Is there anything gets cancelled on both sides? Check. Anything gets cancelled? PA naught XA gone, huh? PA naught XA gone. Anything else? Yes, sir. Minus PB naught into XA also gone. Anything else? Minus PA naught into XA square. One time gone. Sorry, minus PA naught into XA square. This is minus 2 times of PA naught into XA square. One time gone. What is left? PB naught into XA square. One time gone. What is the equation left? PB naught minus PA naught into XA square plus PB naught into XA square minus 2 PB naught into XA equal to quadratic expression you got. It will have 2 roots. Response, sir. What is that expression? PA naught minus PB naught into XA square plus 2 PB naught into XA minus PB naught equal to 0. Correct? Correct or not? Say something. Then what is XA equal to? Minus B plus or minus root of B square minus 4A. Correct? Square. 4A into C. What is C value? Correct, sir? Divided by 2A. Respond, sir. Correct or not? Now, if I take negative, total XA equation becomes negative. Do fractions becomes negative or not? Impossible. I am mixing 2 liquids means always fractions will be positive. Means minus is impossible case. So minus and plus is the only possible case. Now expand. Minus, can I take 2 common? I am cancelling the 2. Here also I am taking 4 out of the roots, becomes a 2. Denominator, numerator is gone. So what is left? XA equal to minus PB naught plus under root PB naught square. This becomes plus PA naught into PB naught minus PB naught square divided by PA naught minus PB naught. Can I cancel this PB naught minus PB naught? These 2 are gone. Response, sir. These 2 are gone. Means what is XA equal to? Minus PB naught plus under root PA naught PB naught upon PA naught minus PB naught. Accepted, sir? Right? Substitute this XA in total P equation. What is total P? What is total P? PA naught minus PB naught into XA Instead of XA, I am substituting this. Minus PB naught plus under root PA naught PB naught upon PA naught minus PB naught. Correct? PA naught minus PB naught into XA plus PB naught. Response, sir. Then this and this gone. Response, sir. Then what is left? This minus PB naught and this plus PB naught is also gone now. Say something. Then what is total P equal to? Under root PA naught into PB naught. That's what I told. If YA minus XA is a minima or maxima, total pressure P becomes equal to under root PA naught into PB naught. Right? Or XA equal to minus PB naught plus root of PA naught into PB naught upon PA naught minus PB naught. What I told you, what is XA equal to? Say this, what is XA value? Minus PB naught plus under root PA naught into PB naught upon PA naught minus that is all waste, man. Right? Differentiation, calculus, math also you are studying waste, people. Shit. No one is studying math. Done. What do you want? Done.
Sir, can you show all the equations once, sir?
Yes, sir. All the equations are shown once. Yes. See the equations. Done, na? This part is done. You will keep on writing. Head. Paste. Over. See how simple it is. Over. If they say number of moles of A in liquid phase, number of moles of A in vapor phase, both are almost the same. Or A is not at all evaporating, mostly B is evaporating. Then also, what is total pressure equation? Root P and R equation. Right? If you want XA value, substitute this P naught into PB naught in this equation. And instead of this P, substitute root P naught into PB naught, automatically we get XA value. Na? Sponsor, over. Right? We are done with liquid composition. Means solubility of liquids in liquids is so only one more part. What is it? Solubility of solids in liquids. Response, sir. Delete. Right, sir. Last part of this chapter, 66% of this chapter is over. Before, what's the time there? 8:50, na? In this liquid compositions, I love one passage. If you are interested, we will discuss. I like the beauty of the question itself. Right? Definitely, it will be not there available in your textbook, in your booklet. I am for sure. Right? When it is a subject to model, when the JEE advanced paper is subject to model, they use it to frame such questions. Right? From last 30 years, they are not even asking any question closer to that also. Understood? They are simply asking, substitute the formula, find the answer. They will give PA naught, PB naught, They will ask P by giving XA. Only very simple. If you substitute, you will get answer. Right? At our time, they used to ask question in this way. Do any of you have VK Jaiswal, N Avasti? Any of you have N Avasti book? VK Jaiswal, N Avasti? Yes or no? Do you have? Now. I will open another book then. Hey, why man? Why you people are laughing? Hmm? What is the chapter name? Ten point one, huh? 10.1. 10.1 means page number approximately 350. Shh, please, 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 sir, stop talking, sir. Right, sir. This is the chapter, sir, we are studying. Solubility solutions of gas and liquid. All these topics are over. So you can solve all these nonsense questions, waste questions, all this. Vapor pressure. Concept is over. You can solve all these questions. Solutions in liquid. Over. You have to solve all these questions. Have you seen something here? Observe the graphs, man. All the equations. These are waste questions. Azeotrope, all we have studied already. This part we need to study. Lowering of vapor means we are going to study about solubility of solids in liquids. That we will discuss in next class. We will see one beautiful question. Then I will stop today's discussion. Osmotic pressure, elevate, all these are level 1 only. We don't want level 1. Right. Here, sir. Let's stop. Question number 5. Can you solve? You know now. It is just like that question. 1 upon XA versus 1 upon YA graph, man. What is slope? What is intercept? Check. What is this people? 1 upon XA on Y axis, 1 upon YA on X axis. What happened? PV naught minus PA naught upon option B. B, Question number 8, sir. Try to understand, sir. Question number 8. Try to understand. Pressure over a ideal binary liquid solution contains 10 moles each of A and B is gradually decreased isothermally. Means without changing temperature, that liquid is decreasing slowly. Means it is converting into vapor. At what pressure? Half of the total liquid will get converted into vapor. At what total pressure? Half of the total liquid converted into vapor. Understand the question carefully. Yes? I don't know. You think and tell me the answer. If you know the idea, it is just like that question. If you don't know the idea, you need to solve. To solve, so much time it will take. That's why I derived it already and I kept it to a small format. So answer is root of PA naught into PV naught over. Just like that question. If you find any passage question, you tell me, sir. Wait. Yes. See the passage, sir. Passage 1. Now it is just a fraction of seconds question. If you don't know, it is very big question. If you know, it is just a fraction of second question. First one now. What is the first question answer, sir? The value of XA for which YA minus XA is minimum. What is the value of XA for which YA minus XA is minimum? Yes, sir. What, sir? Yes, sir. Something wrong. In denominator, they missed something. What is it? PA naught minus PB naught. They missed that in the denominator, sir. Correct? Subtract -1, sir. In that equation, subtract -1. Are PA naught minus PB naught, na? In denominator. Your choice. Or multiply with PA naught by PB naught, PA naught by PA naught. Subtract PA naught or minus PA naught plus PA naught. Subtract PA naught, add PA naught. Right. Equation minus PA naught plus PA naught is means you are not doing anything, na? Then check. You gave up. At least give this answer. Second question. The vapor pressure of solution at this composition. At least that one. Wow. This is the beauty, sir. I want to solve this question. Solve. Those who are able to solve this passage, right? Tomorrow itself, go to your IIT of your choice. Take a kerchief, put it in your chair of your choice, in your respective department, and come back. After 1 year, go and collect the kerchief. For sure, I am saying. Solve. Right. Liquids A and B form ideal solution. PA not given, PB not given. In a cylinder piston arrangement, 2 moles of vapors of liquid A, 3 moles of vapors of liquid B are taken at a T Kelvin 0.3 bar. So there is a gas cylinder. The gas cylinder have A liquid, vapor A, vapor B. Both are present inside that cylinder, which can be having a piston. Now what they are saying, predict whether the vapor will condense or not at the given pressure. At a given pressure, whether it will condense or not. Listen. It is having, listen, it is a cylinder, na? Fitted with some frictionless massless piston. Correct, sir? Respond. What is pressure outside the cylinder, sir? What will be the pressure outside the cylinder? Atmospheric pressure, P atmosphere, which is equal to 1 atmosphere. Correct? What is P of gas now? What is it? PA naught minus PB naught into XA plus, correct? So what is it? What is PA naught minus PB naught? minus 0.2 bar. So minus 0.2 bar into what is XA? What is XA? They are asked given XA or YA value. So they gave XA value or YA value, sir? YA value, na? Then how you will get it? What you will get now? Now can I write P equal to PA plus PB, where PA equal to YA into P, PB equal to YB into P. Correct? What is PA equal to? PA naught into XA is equal to YA into P, or PB naught into XB equal to YB into P. Correct, sir? Instead of doing all this nonsense, I told you one thing. 1 by P equal to YA by PA naught plus YB by PB naught. When there exists equilibrium between liquid phase and vapor phase, whether I give the equation or not. Point number 4, I think. 4 or 5? Huh? What I told you? Instead of all this nonsense. What I told you, sir? When there exists equilibrium between liquid and vapor, 1 upon P equal to YA upon PA naught plus YB upon PB naught. Correct? So 1 upon P equal to what is YA given? 2. PA naught given 0.4. What is YB given? Hey. 3, hey. Hey. It is not 2. It is a 2 upon 5. This is number of moles of A. So it is 2 upon 5. Correct? Upon 0.4 plus 3 upon 5 into 5 upon 0.6. So 1 by P equal to what is that value? 0.4 how many times, sir? 0.4 how many times? So this is 1 plus 0.6 how many times, sir? So 1 means P equal to means what is the pressure generated if liquid and vapor both exist equilibrium here? 0.5. What is the pressure outside? So outside pressure is greater than pressure that can be generated when there exists liquid and vapor. Then what happens? Do vapor readily converts into liquid or not? Read the question. Yes, complete condensation may happen. Why, sir? The outside pressure is double the top pressure which is generated inside. Correct, sir? Correct or not? If I got this value as 1, if I got this P value as 1, means what is the meaning of it? There exists equilibrium, means amount of liquid generated is negligible. But outside pressure is far higher than inside pressure, means what is the meaning of it? The atmosphere will push the piston down. If atmosphere pushes the piston down, what happens to all the vapor? Converts into liquid. So what should be the answer? Correct? Now come to next question. If the vapors are, yes sir. Partial condensation occurs, means only means these two values are approximately same. Then partial condensation. Exactly same. Then just now equilibrium reached, means hardly a drop is found. Correct or not? Here almost condensation happens. Reason? Outside pressure is almost double that of inside pressure. So almost complete condensation happens. Clear? Right. If the vapors are compressed slowly, at what pressure? The first drop of liquid will appear. No. Listen to the question carefully. The vapors are compressed slowly. At what pressure? The first drop of liquid just to form. Liquid just to form. Yes. Say something, sir. Huh? 0.5 atmosphere. 0.4 atmosphere.
Sir, third option was.
Just now we calculated. Right? There exists equilibrium between liquid and vapor. Means first drop of liquid form. That is the meaning of it. Na? Question how to say. The first liquid drop obtained. First liquid drop obtained means there exists equilibrium or not. Yet that equilibrium, what is the pressure? 0.5 is the pressure. Respond. Next question. If the initial drop of vapor was 10 decimeter cube, if the initial volume of vapors was 10 decimeter cube means 10 liters. Total volume of gases is 10 liters. At what volume the first drop of liquid will form? If initial volume of the container is 10 liters, then what will be the volume of container
Sir, first
when the
option.
first drop is formed? Yes. When pressure becomes equal to 0.5, first droplet will form. What is the initial volume now? What is the initial volume? This is the partial pressure of B. This is PNR. This is PB0. This is the temperature. These are the number of moles given. Can you calculate what is the volume of container by assuming the temperature as 25 degrees centigrade? Say something. Possible or not? Say, sir. Can you do it? Who knows? I will do one thing. Take the screenshot of this question, this passage. Show me the solution. I don't want answers. You need to show the solutions for all the questions by next class. We have next class on Tuesday. Again, we have 2 classes, not Tuesday. What's that? Huh? Take the screenshot of it. Try. Understand slowly. Read it. Solve it. Alright, listen. Again, I am saying, when we are discussing theory, are you able to understand the theory or not? After you said yes, then only I went to solve the numerical. Correct or not? Alright, say something. Then problem is your way of adapting the theory. So you need to practice that. How I need to adapt to that. We have to adapt to. Okay, don't worry. I will post in this image only, na. I will post that in your channel.
Sir, can you upload the notes of the first 2 classes?
If you want, I will upload the previous chapter, previous year's note. Where I can keep. Here I will upload.
Okay, sir.
I am uploading here, ma'am. Complete chapters notes I have uploaded, ma'am, including colligative properties also. Right? In SR01 also I am uploading. SR01. Where is 2025 SR01? I posted that image also, man. Solve it. And in EW02 also, I am posting that image. Solve it. Right, sir? Right? So I posted that image, sir. Solve that question. The passage. Done? I will end the session.
Thank you, sir.
Thank you,
Right,
sir.
Thank you,
Hey,
sir.
listen.
Thank you, sir.
Don't give up by saying that it is out of my range. Huh? I have given up. Right? You need to try to understand the theory. Now the problem is how to link that theory, what you have learned, how I need to link that to this given question. Then your thinking process will start. Thought process will start. Right? Till now, what you are practicing is, I am saying, including math. I never saw math paper, how easy that you have, it was given to you complete year last. I never saw that. I don't call it as math paper. It is a paper given for 50th class, 6th class. Really, you will see real math paper in final. You might have saw JEE mains papers, not final. That is real math paper. That is also mains level. Advanced level papers we have not at all seen. Right? If you don't start thinking, you will never improve your skills. Right? Most of the times where you will get deceived, deceived completely is you will always solve easy questions where you will substitute formula by solving, you will get the answer. You feel that? Right? That is where you are understanding the theory over. Where you are applying. You need to apply your skills, na? To apply your skills, where you have to do? Questions where you should not understand, sir, what I have to put in it. Which formula I need to put. That also you should not understand. Then you will start thinking. When you start doing that for every question, every chapter, if you do that continuously for 1 year or 2 years, then your plane of thinking will change. Once you come to that plane of thinking, you are really in competition. Till then, you are constructing your base. You are not coming to competition. Following, you are this Mukesh, your guy only, na Tamil guy. Mukesh, chess champion. Yes. Gukesh, Mukesh, someone, right? Gukesh. Yes, same, right? Everyone knows same rules. Do you know anything extra? Or he is playing with the extra coins, extra pawns, extra what we call as his board is having extra things, or his board is less, or something like that. No, everything is common. Then what is the difference between him and others? What is the difference? We will generally think about the next move. Or when I have made one move, you will think how to protect your partners. Correct? How to protect your things for the next move alone. You will not think about if I move this, what are the possibilities that he will move? What may be the next move? If you do that, what I have to move? In that way, you have to think till the last step. Based upon your plan, based upon your strategy, you need to provoke your opponent to make the mistake, to trap him into your steps. if you are luring him to your steps, your plan, then game is in your hand. So the skill is predicting all his possibilities and luring him towards your plan of action and winning the game. Correct or not? So when it will start? When you start thinking, no? Correct? So if you don't start thinking at all, substitute, calculate, when you will start thinking? Correct or not? So take such challenges. Try. For sure you will not get it. I will help. At least imitate me how I am solving. I am also average guy. I am not extraordinary person. If I am extraordinary person, for sure I will not teach you. I might have joined in MIT or Stanford University or somewhere. I might be professor at NASA or scientist at NASA. Correct or not? I am here means I am also average guy. Maybe even my brain is not as active as yours also. That's why I became teachers. Keep also this mind. 99% of teachers who are teaching you are at least 1 upon 100 part also not equal to your capabilities. If they are so experts, definitely they will not be here. Simple logic. Are accepted or not my logic? Correct or not? Are yes or no, man? Right? So don't think that sir is doing, I am not able to do it means. An average guy, this idiot is doing, why I can't solve? You need to think in that way. Right? I have seen people who are earning in crores. For one lecture, there are people who are charging 5 lakh rupees per lecture. One lecture he gives means 5 lakhs he will take and go. There are such efficient people. We will never come across to such people. Correct? They are really professors. If I am doing means you can do it easily. But problem is you are not trying to do it. At least you are not trying. If you try, you can do better than me. For sure, I am saying for sure, 100% sure I am. If you start thinking, try to solve the numericals, you can do better than me in a easier way, in faster way also. Not only me, in all subjects I am saying. Okay. Right. Carry on, sir. I will end the session.
Sir,
Yes, sir.
so Monday and Tuesday I was not able to attend the classes for chemistry. Sorry, Monday
Very
alone.
good. Very good.
Ah.
Monday, there is no chemistry class. I had chemistry class on Tuesday and Thursday. Correct? Sorry. Monday and Friday. Yes. You missed Monday class, I think so.
So for that, can I get a backup session tomorrow? Can I come there around 12 or something?
You can come. I will arrange some faculty to teach you. No issue.
Okay, sir. Okay, thank you.
Right, sir. Yes, madam.
Sir, tomorrow
Yes, sir.
classes there or not, sir?
Why, sir? Yes, Shivaganesh.
Sir, tomorrow classes there or not, sir?
Classes are there now.
Okay.
Oh, you are saying weekend?
For us will be there or not, sir?
Array. Regular students, weekday students will be weekday only, weekend students will be weekend only. But what I am doing is, I am sharing the link of weekday to weekend also, weekend link to weekday also. So that if you miss, at least you will listen to that classes. Understood?
Okay, sir. Same portion will be taught, sir.
Obviously, till
Okay,
Friday,
sir.
whatever we have taught, same thing we will teach on Saturday and Sunday also. Correct or not?
Okay, sir.
Yes, madam. You also understood now?
Yes, sir. But I'm not
So you
getting
can-
the link for weekend classes.
For weekend classes, you are not getting the link. I will inform.
Yeah.
Or you try
Okay,
to
sir.
come here. You can utilize that relaxedly 1-to-1 session you can attend. That will be sorted out. Okay.
Okay, sir. So where can I see the notes uploaded?
Upload notes in your channel. I will show it one more time. This is your channel, right? You are into which channel? SR01?
SR01.
Click it. Go to chemistry. There you can find files on the top. Right? Wait, where is the notes, man? Files. Just now I uploaded, na? Where it is? Someone deleted or what? Here. Visible?
Yes, sir.
Right. I'm closing the session. Bye, sir.
Thank you, sir.
Bye, sir. Santoshni. Bye.
Thank you, sir.
Yes, sir.
Thank you.